Good evening. Tonight we're going to discuss relative density and floating versus sinking. Relative density refers to the comparative density of two or more substances or objects. So basically what you're doing is you're going to compare the density of two different objects. So in essence, what you're really doing is you're looking at how the density of one substance or object compares to the others around it. And what you'll find is objects that are more dense than the substance they are in will sink, and if they are less dense than the substance they are in, they will float. Or you'll find that objects that are more dense than the substances they are around will sink towards the bottom, and objects that are less dense than the substances they are mixed in with will tend to rise to the top. This here is an example of what we call a density column. Okay, here you'll see that the red liquid is less dense than the clear liquid, which is less dense than the blue liquid. So you'll see these several different liquids here, and you'll see these three different liquids floating on top of the one beneath it. So in this example, we said the red is less dense than the clear, which is less dense than the blue. We can make that statement because we can see that the blue liquid sank to the bottom, so that means it's more dense. The clear liquid sank below the red liquid, so it's more dense than the red, but it's not as dense as the blue liquid, which is why it doesn't push all the way down. Now you'll see this white object inside this density column, and you'll notice that it sank through the red liquid and through the clear liquid, but when it got to the blue liquid, it stopped, which tells us by comparing densities of the liquids that this little white object is more dense than the red liquid, more dense than the clear liquid, but not as dense as the blue liquid, which is why it floats on top of the blue liquid. Just make sure you understand that the reason it was able to sink through the red and clear liquids is because it's more dense than them, and the reason it floated on top of the blue liquid is because it is less dense than them. Here we see two density columns, one with just liquids of various densities in it, and the other one with liquids and objects in it. Note that the substances that are most dense sink to the bottom, and the substances that are least dense rise to the top. Okay? You can obtain some very important information from these density columns. For instance, you could state qualitatively that this plastic object is more dense than the corn oil because it sank through the corn oil, but it is less dense than the water because it's floating on top of the water right there. It stops when it gets to the water. Now you'll see here that they wrote down for you the various densities of these objects. But if you didn't know the exact density of this tar ball, you can make a quantitative statement that this tar ball has a density that is between 1.0 grams per milliliter, or grams per cubic centimeter, and 1.26 grams per milliliter, or grams per cubic centimeter, because you see that this tar ball, while it sank through the water, stopped and did not sink through the glycerin. So it's somewhere, its density is somewhere between these two numbers, and that is a quantitative observation, okay? So you can gain a lot of information from these density columns based on the position of the liquids or the objects in them. Here you'll see an iceberg, and based on the position of this iceberg, it is floating. So you know that this iceberg, based on its density, is less dense than the liquid or the ocean water that it's in. So the reason this iceberg floats is because it's less dense than the ocean water. Here we have an experimental setup where we see two eggs, one floating in a clear liquid and one sinking in a clear liquid. Now, what can we tell from this information? Well, we can make a basic statement about this. This egg right here, we'll call this setup B, is floating because it's less dense than the liquid it's in. The egg on the left in setup A is more dense than the liquid it's in. Now, what can that tell us? Well, assuming that both eggs have identical densities, that would tell us that the liquids are not the same. Because if the density of the egg in setup A is 1.5 grams per milliliter, and it's 1.5 grams per milliliter in setup B, that would tell you that the liquids have different densities, because the liquid in setup B would have to be more dense than 1.5 grams per milliliter if that egg is to float. We know that because objects that are less dense float, so 1.5 grams per milliliter would have to be less dense than the liquid it's in. In the other setup, setup A, we would find that the egg is more dense than the liquid it's in, which would tell you that the liquids are different. Okay? So this liquid in A is less dense than 1.5 grams per milliliter because the egg is sinking. We can now determine that these are definitely not the same liquids. They are a clear liquid, but they are different because they do not have the same densities. And liquids that are the same will have the same densities. Now let's erase this and check out a different scenario. Now, if we were to assume that these are the same liquids in each glass, that would tell us that the eggs have different densities. And for this example, let's just say it's water, and water's density is 1.0 grams per milliliter. Pure water has a density of 1.0 grams per milliliter. If this is the case, we know that the egg in setup A is more dense than 1.0 grams per milliliter, and the egg in setup B is less dense than 1.0 grams per milliliter. And we can make that statement because one is floating and one is sinking. Okay? Something that is less dense than 1.0 grams per milliliter will float in water. Something that is more dense than 1.0 grams per milliliter will sink in water. Okay, so I hope you understand how we calculate or determine relative density. It's basically comparing the densities of two or more substances to each other. And based on their position to each other, we can determine which one's more dense. Okay? That's all we have for today. If you have any questions, please come see us. Okay? Have a good night.